everybody okay? All right, so guys, we're going to get back into the solving, right? We are solving quadratic degree 2 equations, so we're still going to get 2 answers to these equations, but we're just going to do it using a different method. We saw how to do it by factoring, but guys, unfortunately, not every quadratic expression can be factored. You can't always find these beautiful numbers to do everything that you need to do. Unfortunately, sometimes the answers to a quadratic equation are just ugly decimals, and you can't get that from factoring. So there's got to be other ways to solve a quadratic equation other than factoring, and there are 2: square roots and the quadratic formula. I'm going to show you how to solve using square roots today, but guys, unfortunately, square roots is yet another method that will not solve all quadratic equations out there. The square root method can only solve a special kind of quadratic equation as well. The only way to solve a quadratic equation, no matter what it looks like or what its answers are, is by using the quadratic formula. And that's the way you guys learned last. That's the only method that can solve every single quadratic equation out there. Factoring and square roots only work for certain quadratic equations, right? But it's still a good method to know because they're quicker than the quadratic formula, okay? All right, so here we go. So we're going to solve quadratic equations using square roots. You can only solve a quadratic equation using square roots if there is no bx term. So guys, the only thing the equation can have is a squared term and a just number. There can't be any just x's in the problem because we can't use a square root to unsquare a just x if we don't know what x is. I can unsquare a number and I can unsquare an x squared, but I can't unsquare a just x. So there cannot be an x term in these equations if you want to solve it using square roots, okay? All right, so once you establish that this equation is okay to solve using a square root, these are the steps you're going to take. The first thing you want to do is get the x squared term, or sometimes it's not an x squared, it's an entire parenthesis that is being squared. You want to get either one of those completely by itself on one side of the equal sign. Then you're going to take the square root, you're going to unsquare both sides of the equation. You're going to not forget the plus or minus sign, and I'll explain that when we get to it. And then you're always going to make sure your answers are simplified. We always want to make sure that our square roots are in simplest form, okay? All right, let's give this a whirl, guys. Let's try it. Let's try to solve quadratic equations using square roots. I've broken it up into 3 parts. There's like 3 different types of questions that you're going to see on your homework. So I just broke them up so you can see when each kind of equation changes. All right, so here's part 1, probably the easiest kind. Let's say you were asked to solve this quadratic degree 2 equation for x, right? All right, well, notice there's an x squared and there's a just number. There's no term that is just that x term. So that means this is safe to solve using square roots. So your goal is to get x squared by itself. So -8 and +2, we got to move them away. So just like normal, let's use our opposite operations to do this. Let's add the 8 away, the one that's not attached first. Right? So now we're going to get 2x squared equals 8. Now remember, only the x is being squared, so we still don't want the 2 there. Make sure you move the 2 away as well. So now we're going to divide the 2 away because it's being timesed. So we'll do the opposite. And then you get x squared equals 4. Well, there it is. Our job is to get x by itself now, right? So now that I know x squared equals 4, I'm trying to figure out, well, what number or numbers did I square that could make 4, right? What's the answer to this problem? Well, just like before, using opposite operations, how do we unsquare something to get x by itself? We take the square root of it. We're going to square root both sides of the equal sign. So now, guys, when I take the square root of this square, those operations cancel. Square rooting and squaring cancel each other, and they leave me with just x, which is what I want. All right, now we're left to say, okay, what's the square root of 4? And that's nice. It's 2, right? Okay, technically I did the problem wrong on purpose just to show you guys something. It says right now the answer is 2, right? Which isn't completely wrong. But guys, this was a degree 2, a quadratic equation. I only got one answer. I'm supposed to get 2 answers, right? I'm supposed to get 2 different answers, or I'm supposed to get the same answer 2 times. Well, where's my second answer? The second answer comes from this. Guys, think about it. The original equation said x squared had to equal 4. Is 2 the only number in this world that I could square to equal 4? Or is there another number that I could also square that would get me 4? Think about that for a second. 2 times 2 is 4. 2 squared is 4. But is there another number that also, when I square it, I get 4? And guys, there is. -2. -2 squared. -2 times -2 is also 4. So in reality, when you square root both sides, you're actually going to get two versions of this answer. You're going to get the positive version and the negative version, because both of them squared would make this true. So the way we show the two answers that you're getting a positive and a negative version of your answer is we say x equals plus or minus 2, and you get a plus or minus answer. And it's showing you that there are two possible answers. One answer is when x is 2. The second answer is when x is a -2. So those are your two answers to this degree 2 quadratic equation. So guys, every single one of these answers is going to have that plus or minus. We're going to get a positive and a negative version of all of these answers, okay? And that's how we create two answers when we're using square roots. Now, Delta Math tonight. Delta Math will let you type it like this. Under your answer box, they're going to have a little plus or minus sign that you're allowed to click on. So you can click on the plus or minus sign and then type a 2 in your answer box, and it will accept plus or minus 2. Or you're allowed to write them as two separate answers, but then you have to hit that little plus sign to create the second answer box. One answer box you would put 2 in, the second answer box you would put -2 in. So it's your decision. Do you want to write them as two answers together, or do you want to write them as two separate answers? But at the end of the day, we got 2 and -2 as our answers. All right? Can I get a thumbs up if that makes sense? If there's two answers to this equation, 2 or -2? Excellent. All right, here we go. Because the biggest mistake with these is people just put 2. They forget the plus or minus sign. Let's try it again. Same thing. There's x squared. Our job is to solve this for x. So let's get x squared by himself so I can unsquare it. So we're going to add the 28 away. All right, I get 1/2 x squared equals 10. You have two options to get the 1/2 away. I could divide it away like I normally do to things that are attached to x squared, or I could times by 2, because when I times 2 and a half together, they cancel. I just get 1, which is 1x squared, which is x squared. So you do whichever way you like to do. All right, and then I have to times this side by 2, and I get 20. All right, so our job is to figure out what numbers could I square to get 20 as my answer. All right, well, to find this out, now that we have x squared alone, let's unsquare it. Let's square root both sides. The square root and the square cancel each other out, and they leave me with just x. It's going to equal, guys, two answers, the positive answer and the negative answer. So the minute you take the square root of both sides, you're going to get a plus or minus version of this answer. All right. Well, guys, think to yourself, you got to take the square root of 20. Can you take the square root of 20 and get a whole number? No. But can you simplify the square root of 20? Do any perfect squares divide evenly into 20? And yeah, what's the biggest perfect square that divides evenly into 20? 4. So I can simplify this into the square root of 4 times the square root of 5. And then x will equal plus or minus. The square root of 4 is 2. And then we times it with the square root of 5 that stays. So your two answers are, one of them is when x is positive 2 times the square root of 5, which is just a really ugly decimal, guys. The square root of 5, anytime you take the square root of a number that you can't take the square root of, it's an irrational number, a really long, non-ending, non-repeating decimal. So 2 times the square root of 5, guys, it's just a really ugly decimal. And we don't want decimals. We want nice, exact answers. And then the second answer is -2 times the square root of 5. And those are your two answers to this degree 2 quadratic equation. So again, you can write it like this as one, or you can write them as two separate if you like to see it. And guys, at the end of the day, can everybody remember what we're finding? When you find these x values, those are the x-intercepts of the graph of all of these parabolas. His parabola would cross the x-axis at positive 2 and -2. His parabola would cross the x-axis at 2 times root 5, which again is just an ugly decimal, and at -2 times the square root of 5, which is just an ugly decimal. Don't forget, when we solve these quadratic equations, what are we solving for? We are solving for his x-intercepts of his graph. All right, let's try it one more time. I'm going to give you guys a little bit of a head start on this last one, and I'm going to check the attendance while you guys get a head start on this last one. Solve that for x. Get x squared by itself so you can square root both sides. Let me. Ian is here. Josh is here. Kyle's here. Sophie, Ty, Alexander, Zach. No, Ethan's usually here. No, Josephine. Is Larry here? Larry's here. No Larry. And no Yusuf. Okay. All right, let's look at this one. So the first thing I would do to get x squared alone is I would add that 8 away, right? The one that's not attached. So let's add 8. And I get negative 3x squared equals negative 2. I'm going to divide by negative 3, get x squared completely by itself, and I get x squared equals 2/3, right? So now that x squared is by itself, we can take the square root of both sides. So I can unsquare it, square root, square root. The square root and the square will cancel. I'll be left with just x. It will equal, don't forget, I'm going to get two versions of this answer, the positive version and the negative version. All right, now look, we're asked to take the square root of 2/3. I would first look at 2/3 to see if he reduces, but he doesn't. Now I'm going to split them into their own square roots like we saw yesterday. The square root of 2 divided by the square root of 3. And now let me look at them individually. Can I take the square root of 2? Mm-mm. Can I simplify it? No. Can I take the square root of 3? No. Can I simplify it? No. So it looks like you're done, but remember, we're not allowed to divide by that irrational number, the square root of 3. So we're not allowed to have the square root of 3 stay in our denominator. So we're going to create a square to get rid of it. We're going to times top and bottom of this fraction by the denominator, the square root of 3, right? We're going to create that square. So then we're going to get our answer. Don't lose the plus or minus sign. It'll be plus or minus. The square root of 2 times the square root of 3, put them back together as one square root, which is the square root of 6, 2 times 3, over the square root of 3 times the square root of 3, right, guys? That's the square root of 3 squared, or it's the square root of 9, which is just 3. So I no longer have a square root in my denominator. Now, the only thing you would want to double check before you say you're finished is make sure that the square root of 6, this new square root that you've created, make sure he's simplified. But the square root of 6 is a simplified square root. No perfect squares will divide evenly into it, so you're good to go. So one answer is when x is positive square root of 6 divided by 3, which again, it's just an ugly decimal. And the second answer is when x is the negative square root of 6 divided by 3, which is just another ugly decimal. So again, you have just found out the x-intercepts of his parabola. These are the x values where his graph will cross over the x-axis. All right, so guys, that's the first kind of problem that you are asked to solve by square roots. Can I get a thumbs up if that feels okay? Hopefully it feels better than the factoring, right? It's not as much thinking. You don't got to sit here and figure out numbers. You just do the math, right? Do all the opposite operations. All right, now let me show you the second kind of equation that could pop up on your homework. This is part 2. So now, guys, if you look at part 2, look at these two equations. The only difference from before is now that x squared that you're trying to get by itself, it's just stuck inside a parenthesis. So we're going to have to get it out of the parentheses in order to get to it. So let me show you the easiest way to do that. So if we have to get x squared by itself, right, he's stuck in these parentheses, I'm going to move the one that's not attached to the parentheses away first, like normal. He has nothing to do with what's inside or the outside of these parentheses. So let's get this positive 5 to the other side. Let's minus it. Okay, so now I have 5 times the quantity x squared minus 6 equals 0. Okay, well now, how are we going to get rid of these parentheses, right? How are we going to get inside those parentheses to get to that x squared? Well, guys, you have two options. If your gut was saying, oh, I should probably distribute, right? Get rid of the parentheses. So I get 5x squared minus 30 equals 0. Guys, you're not wrong. You could totally distribute. But I'm going to try and save you a step. Instead of distributing it, and then you're just going to have to divide it out in the end anyway because you're going to create a 5x squared, why not just divide them out right now? Don't even bother multiplying it in. Just divide them away right now. If this is 5 times that parenthesis, forget it. Let's just divide by 5 and cancel them out right now. Divide him away. And then I'll divide this side by 5 as well. So then I'm left with, now I don't need the parentheses. It's just x squared minus 6 equals 0 divided by 5 is still 0. So now I can get to that x squared. So I'll add the 6 away and continue on with my solving to get x squared alone. And I get x squared equals 6. Now that x squared is alone, I'm trying to find out what numbers could I square to equal 6. Well, to find that out, let's unsquare them. So let's take the square root of both sides. The square root and the square will cancel, and it'll leave me with just x. Now remember, when I take the square root of a square, it's going to create two versions of my answer, the positive version and the negative version. Well, guys, look at the square root of 6. Can you take the square root of 6? Nope. Can you simplify the square root of 6? Do any perfect squares divide evenly into 6? No. Great. Less work for us. We just leave it as the square root of 6, which again, that's like 3 point something, okay? It's in between the square root of 4 and the square root of 9. It's just 3 point something. It's a very ugly decimal. So one answer is when x is positive square root of 6, so 3 point, I don't know if it's 4 or something-ish, all right? Or when x is the negative square root of 6, which is like negative 3.4-ish or whatnot. So you just get two separate answers. Everybody okay with that? All right. Now, again, you're allowed to write your answer like this on Delta Math, plus or minus. They'll have a plus or minus sign, and they'll have a radical button for you. They'll have a square root button that you can click on just to start typing under. All right. So you can write it as two answers as one, or you can write them as two separate in their own answer boxes. All right. Let's try this kind again. All right, so look at the next example. Same thing. See how that x squared is in those parentheses. We got to get them out, right? So let's work to get rid of these parentheses. So again, I'm going to move away the 9, the one that has nothing to do with those parentheses. He's not attached. He's not inside of them. Just move it away. So now I have 4 times x squared minus 3 equals 20. And again, you have two options. You could distribute the 4, but why bother? Just get rid of them right now. Divide them right out and create less work for yourself. All right, so now I'm left with x squared minus 3 is free now. They're out of the parentheses, and it equals 5. Okay, well, now let's just continue on with our solving. Let's work to get those x squareds by itself. So let's add that 3 away. And you end up with x squared equals 8. Okay, we're there. What numbers can I square to equal 8? Because those numbers are my answers. Well, to find that out, let's unsquare. Let's square root both sides. All right, the square root and the square cancel. I'm left with just x. Well, when I take the square root of a square, I really have two different numbers I could have squared to get 8. So there's going to be two answers, the positive and the negative. All right, now look at the square root of 8. Can you take the square root of 8 and get a whole number? No. But can you simplify the square root of 8? Is there a perfect square that will divide evenly into 8? What's the biggest one? It's 4. So we can simplify this. We'll make it the square root of 4 times the square root of 2. And then x will equal plus or minus. The square root of 4 is 2. And then we times it with the square root of 2. So your two answers are when x equals the positive 2 times the square root of 2, which again is just a really ugly decimal, or when x equals negative 2 times the square root of 2, which is just an ugly, ugly decimal. And those are this parabola's x-intercepts. That's where his graph would cross over the x-axis. Okay? Is everybody okay with that part? Everybody's good? Okay. Well, now here's the third and final kind of question. And this one, I would say, I don't know if it's the hardest, but it definitely, involves the most. So watch this one. It's probably a little bit different than some things you've seen before. When you go to solve the last ones, now it's not x who's going to be squared, but it's going to be an entire parenthesis that they have squared. That's okay. Guys, as long as something is squared, we can unsquare it, right? So I know this one has a just x in it, but because he's in the parenthesis squared, it's okay. Because if I squared this parenthesis, he'd end up being an x squared. So it's okay. Don't worry. Because that parenthesis is squared, we're going to be allowed to use a square root. But notice, it's not x who is squared here. It's not x who is squared. It's the entire parenthesis that is being squared. So in these ones, your goal should be to get that parenthesis squared by itself. So my goal is to get this -20 and this +3 away from the entire parenthesis that is being squared. So let's add the 20 away. And you get 3 times x plus 2 squared equals 27. Now, when you get to this step, here you don't actually end up with the option to distribute the 3, because according to PEMDAS, we would square this before we multiplied by 3. So in this case, you don't even have the option to distribute. You have to divide, because you would never multiply before you square. So in this case, you have to divide the 3 away. And then it leaves you with x plus 2, the whole thing squared, equals 9. Okay. Well, guys, I know it probably looks weird, but here's the thing. We have a quantity squared. As long as I have something that is squared by itself, I can unsquare it by taking his square root. So now that I have what's being squared by itself, we can square root it. We're going to square root the entire parenthesis squared. Because when I do that, what does this square root do to that square? It cancels it, and it just leaves you with the x plus 2 that was underneath that square root. All right, and then if I square root this side, I have to square root that side. But again, if this is being squared, there's 2 different numbers I could have squared to get 9. So we're still going to get the plus or minus version of this number. And guys, what's the square root of 9? It's 3. So it's plus or minus 3. But here's the weird thing. Usually at this point, we're done, right? But we're not. X is not alone yet. So we're still going to work to get x by itself. So let's minus the 2 away from him. Okay. But guys, you really can't minus 2 from the 3 because it's really not a 3. It's a positive and a -3. So what you're going to do with this number that you move over, you're going to shove it in front of the plus or minus sign, and you're going to create a little mathematical expression. So now you're going to get x equals -2 plus or minus 3. And now you're going to work out the 2 scenarios individually. Guys, this is telling you that you can take -2 and you can add or subtract 3. So let's break that up into 2 separate scenarios. First, we're going to take the -2 and we're going to add the 3. Then we're going to take the -2 and we're going to subtract the 3, and we're going to create 2 separate answers to this equation. So what's -2 plus 3? +1. So x equals 1 is one answer to this problem. But what if I took -2 and subtracted 3? Then I would get x equals -5. And that's your second answer to this degree 2 quadratic equation. Is everybody okay with what I just did? Is that all right? So again, because this was a perfect square, it left us with an expression that we're able to do. We're able to do -2 plus or minus 3. You just got to do them both separately, okay? All right, let me do one more of these. All right, so look at number 7. Same thing. It's not x who's being squared. It's the entire parenthesis that's being squared, which is okay. Just get that parenthesis by itself. So this negative sign, or this -1, if you want to think of it as, and this +4, they got to go. So let's minus the 4. So now it's a -1 times x minus 5 quantity squared equals -7. And again, I never want to take the square root until what is being squared is completely by itself. And right now, this -1 in front is not being squared. So I have to get that away. So we have to divide it. We cannot distribute it. Divide by -1, divide by -1. And then x minus 5, the whole thing squared ended up equaling +7. All right, so now here it is. I have something squared. What numbers could I have squared to make this equal 7? Well, to find that out, let's unsquare both sides. Let's square root the parenthesis. It'll cancel. It'll just leave me with x minus 5. And then square root this side. It'll equal, don't forget, there's two versions of this that could make this true, the positive and the negative. Well, guys, can we take the square root of 7? No. Can you simplify the square root of 7? No. So he has to stay the square root of 7 because otherwise I'd have to round him to an ugly decimal, and I don't want that. We're going to leave him in his exact simplified answer, which is the square root of 7. All right, but again, we're not done. We still have to get x by itself. So let's add that 5 away. Same thing. I can't add 5 to that number. It's plus and minus square root of 7. So we're just going to shove it in front of that plus or minus sign. And you end up getting x equals +5 plus or minus the square root of 7. Now, in this case, when I break these two answers individually up, one scenario is if I took 5 and added it with the square root of 7. And the second scenario is if I took 5 and I subtracted the square root of 7. But guys, I don't actually want to take the square root of 7 and get this ugly decimal and then add it with 5. So we just leave it in its exact form, just like this. So your answer is x equals 5 plus the square root of 7. That's the exact answer. Otherwise, I'd have to get a decimal for this, add it with the 5, and now my answer wouldn't be accurate. It would be an estimated answer, and we want the exact answer. Same thing. X equals 5 minus the square root of 7 is your second answer, because I don't want to take the square root of 7 so that I can take 5 minus it. Otherwise, it would be an estimated ugly decimal answer, and we don't want that. All right? Those are your two answers to this degree 2 quadratic equation. So guys, on Delta Math, you could type this, 5 plus or minus the square root of 7, or you could type the two individual answers. This one, you had to break it up because I was able to do this. I was able to take -2 and add or subtract it with 3. Here, because I can't actually add them together or subtract them, you're allowed to leave them as one answer, but not here. Okay? Does that make sense? Is everybody okay with that? All right. All right, good. So those are all the questions that you could see on tonight's Delta Math homework. These are all the different kinds of equations that you will be asked to solve using square roots. All right, guys, don't forget, yesterday's homework on simplifying square roots is due tonight. These problems on Delta Math on the solving, I did not make due until Sunday night. You have 10 problems on Delta Math that will be due Sunday night, so you have all weekend to get them done. All right, let me double